All right, welcome everybody to our Collaboratory Against Hate seminar. Giving people a couple of minutes to join here. We're really delighted today to have one of our own faculty members from the Collaboratory at Pitt, Michael Colaresi, to give a talk to us today about some of the research that he's been doing, and I understand some ideas about things that he would like to do going forward, and work with other researchers on. Michael is a computational social scientist, and his background is in modeling information systems and political violence, Bayesian statistics, machine learning, and Texas data. And he has co-founded the Pitt Disinformation Lab and interdisciplinary major in computational social science at the University of Pittsburgh, and founded the Social Science Data Analytics Initiative at Michigan State University. He is currently the research and academic director at the Institute for Cyber Law, Policy, and Security at Pitt. And we are, of course, very proud to include him among our Collaboratory Against Hate researchers. So today, Michael will talk to us about how to understand the uses and abuses of machine learning in democratic systems, which is a very timely topic and has been starting to get a lot of attention. Michael will go ahead and get started. If you all have questions, those of you on Zoom can type them into the chat. And at the end of the talk, we will discuss the questions. So hand it over to you, Michael.
Lori, thank you so much for that very kind introduction. I want to thank everybody for taking the time to be here. As Lori mentioned, this is a talk. It's actually the first time I've given this specific talk, so go easy on me. It sums up how I've been thinking about things, and it violates like the first rule of presentations, which is don't present how you discovered things. You know, the logic of presentation is different than the logic of discovery. But I want to kind of walk through with this group sort of how I got to where I got to, because I think it's a place that a lot of us should meet. And I think the journey there is potentially important. I'll frame this around the title, The Uses and Abuses of Machine Learning in Democratic Systems. And the focus at the end will be kind of about democratic systems. And I highlight that because kind of that's the place I think a lot of us, should meet and focus on across computer science, information sciences, engineering, social science, humanities, community engagement. I'll sort of introduce very briefly here. My work has really moved into a system of systems perspective and an all hands on deck, mode of working on these problems. And so that's what I'm going to talk about a bit today. To frame things for start, a discussion of machine learning, as I'm going to define it, and I'll get to that in a little bit, is not out of place in a discussion of democratic systems, because I view, and I would say Dewey and Lippmann and many of us before, have defined democratic systems as a flow of information. What is voting but communication, right, through specific channels? In fact, I find the Deweyan definition of democracy very, very helpful in that it centers social learning through lateral communication between people rather than top down, through observation and experimentation, that these are fundamental to citizenship and the functioning of democracy. I also think a policy-based focus on consent, right? So the fact that people are learning, that they're figuring things out and experimenting, and that feeds into policy, and it can't be, again, sort of dropped top down, is crucial. And we think about like these are parts of the words we associate with democracy and accountability, representation, free and fair elections, access to information, and in some sense, the liberal component of democracy that sometimes goes unsaid. I also view autocratic systems, and we can think about these as kind of being caricatures or ideal types for a second, as a flow of information, but it's a different type of flow through citizenry and leadership, where we're talking about social control, top-down surveillance, communication, and fear. Policy is generally based on repression of opposition, as opposed to consent, either tacit or explicit. And we think about these also when we sort of define autocratic systems in opposite juxtaposition to democratic systems of unaccountability, non-representative, importance of control of information, and limited rights. So I want you to kind of think about these as systems and start thinking about the information and how they flow, through those systems. And the reason we need to focus on this is because I think we can't take for granted that the flow of information through democratic systems is functioning even the way it used to. And I'm not sure even if it was functioning the way it used to, that it's up to the challenges of tomorrow. And in fact, I think we have to face the real prospect of whether democracies will continue to flourish or thrive, like moving forward, and what will happen. Not only do we see democratic backsliding in places, but deep distrust in intergovernmental organizations, both at the domestic and the international level, polarization, extremism, the sort of shrinking of the things that have defined the democratic community of states, and really like consent not being broad or what we think about as common understandings of values. I find these incredibly worrisome. I also find the social science and computational work that points out these problems to be relatively compelling, that we really do have problems that are they're consistent across democracies, although not the same. And they're working, and the dysfunction seems to be evident across different levels and sort of cuts into the problem. But there's a lot less work on why this is happening. And that's what I want to kind of tackle and focus on. And while I've been thinking about information and democracies for quite a long time, this is my kind of journey to the all hands on deck approach that I now advocate for. If you think about the research question that I'm interested in analyzing, and this is not a talk where I have an answer to this, but I have some hunches and some reasons that I'm going to share, and hope it's enough to get collaborators and build momentum towards this. For all of us, as I think the Collaboratory Against Hate is an incredibly great platform to do this with. Does machine learning, and I'll define that a little differently than how I think most people here will have thought about that. It's really a placeholder for the place where the digital and computing revolutions meet, and where they interact with society. But does this really help autocratic or democratic systems more? That there is a competition in the systems of systems, at the international system, between groups of states. Domestic systems have to function and wish to compete and cooperate with each other in that system. And of course, there's deep embedded technical systems that help define winners and losers. That's ongoing. And my hypothesis that my group is exploring, right, is building on Dewey, which is the idea that today's ML tech, not like any machine learning tech, not what is possible, just today's current state of the art, like it influences the distribution of energy and ordering of political systems in a very particular way. In fact, like I would say and insert that it harms democratic citizens' ability to learn from shared experimentation as compared to less digitally and computationally depended on systems in the past. If we think about like analog and physical systems and material systems that we interacted with, and it actually helps autocratic systems, often just as a service, not necessarily. I'm not blaming Bremen and random forests for surveillance in China, or mass disappearances that are created through GPS systems and tracking, but the services, the information communication technology that's been built within the digital computing revolutions as it intersects with society have helped surveillance and control in particular ways that I think we need to talk about and surface. But I want to start with a caveat. Well, it's like a caveat of a caveat. Like, I love machine learning. I bent my career towards computer and information science from computer science because I was incredibly interested in the way we could process information, right, at this interstice of the digital and computing revolution, right? But the asterisk is there, and what I think I've come to appreciate in getting excited, in getting my, getting into the ring and trying these things out, is that my love is conditional on how we define it, use it, and who has the opportunity and willingness to judge, change, and control it. And I think those things need to be centered in discussions, in particular at the kind of macro level of political and social systems, but also at the micro level. I think we've done a pretty good job. I'll outline like some of the places at the micro level, but I think they hint at a bigger question that needs attention. So what is machine learning? So some people might think it's blue, shiny diagrams of hype. Others might think it's, sort of analogies like Wall-E and Disney. Some might focus on the hardware that enables it to happen, right? The sort of neural engines that are in your phone. And others might focus on, the specific code. I use the term here machine learning instead of big data, artificial intelligence, many other things, data science, because of there's a verb here that I quite like, which is learning. And so you can probably figure that out from my definition of democracy, focusing on social learning. And we have a really good definition of machine learning that I think lends itself to thinking about the uses and abuses of machine learning in democratic systems. And it comes from the definition of Tom Mitchell, yay, CMU, like neighbors, right? A computer program, right, is said to learn from experience E. So I'll use like orange in like text when I'm showing these different colors to kind of think about like data and instances with respect to some class of tasks T, right, and performance measure P. Right. And so like those are just like we need some experiences. There are some tasks and there's some way we're going to measure performance. And then learning, the machine learning is right. If its performance at task T as measured by P improves with experience E, that's learning. So we have components of learning and then how they fit together. That as you get more experiences related to the task as measured by the performance metric, like we do better. I think these pieces, the experience, the tasks, and the performance, and the computer program itself, the code, will be useful for us to focus on. I think everyone here is good, so I don't think I need to define, that there's tasks that are kind of fun examples that you might see on YouTube videos, but there are sort of social and political examples additionally. So political ads being served versus chess. And we can think about those as being tasks with different experiences and performance measures. Here, my work, like I wanted to get my my hands dirty in machine learning over the last about decade or so. So I've applied machine learning models to measuring human rights and forecasting political violence in particular. And also more recently, I'll talk about our work into the disinformation space, where the task might be, let's measure human rights violations protections across space and time. The experiences of the data would be text and metadata from human rights country reports. And we might use something like, F1 balancing precision recall to do well and measure how well our system is performing. And forecasting violence, right? Where is it happening? And we might use something like, mean squared error to see whether we're getting the fatalities right, in a given, let's say, grid cell at a high spatial resolution, for example. Other people let's just think about the symbols here that I'll walk through. The simplest, I think, machine learning examples, right, for supervised learning. So, when I use this G in blue, I'll talk about a computer program or the code of it that has the ability to map sort of features about the world and input data. And that's sort of inputs and outputs, the X and Y. And that's going to involve and create a prediction. The score, our green, is like this target that's going to happen, and models can hit, or miss this target. So this is just sort of ways of thinking about supervised learning, where through this process you want to, use a computer program, right, to minimize or maximize, depending on which way the score function goes. But that's so those are different ways of thinking about the what of machine learning. But remember, I like the verb of machine learning. And so I actually have been the most inspiring thing about machine learning for me, and particularly in getting my hands dirty on this, is actually the how. So I view machine learning as a research design strategy that's empowered by the computational and digital revolutions I'll talk a little bit about in a second. And in particular, for many of us that were trained sort of statistically in frequentist or even Bayesian statistical inference, what we were sort of taught is on the right here, this kind of top down, we have domain knowledge that we're going to test with model representations and fitted models, and then we'll reject, and it's kind of a blind alley of inference. And what I liked about the idea of learning as a verb in machine learning is that there was an iterative flow that David Bly called Box's loop, although in my work, I've added the think person, the think component to this, where we use domain knowledge to build model representations that then compute with training data fitted models. But then, so that's one part of the cycle, which we can think about as kind of sort of aggregate inferences. But we also critique those fitted models on validation data. We come up with discrepancies. We think about what those discrepancies are. Those can be new domain knowledge. We now immerse those measures and inferences in the original context we have, which gives us new domain knowledge potentially of what happens that we could then, do better. So humans in the loop in the machine learning systems that I'm interested in related to politics and society, there's always a human in the loop. Whether they're dizzy or whether they're in control in some sense is the problem. And machine learning as a research design strategy, I believe, is like one way of thinking about how to have control and controlling the process. And this is kind of where I've fallen in love with it. But really, I'm using this definition of machine learning, the how of machine learning, to talk about how the digital and computational revolutions together, right, empower us to process information. So collect and process information. The digital revolution, in some sense, to use the experiences, help us get X and Y, social data, so that like as we're going around, there are digital traces of us and our interactions, that are happening. You can think about stored somewhere, right? And so there are sets of XY pairs of input output observations on us. Yes, this is creepy. Yes, we will return to that. The computational is about the processing of that information and the changing of its state. And so we can think about, server blades blending, right, that data into signals in various ways. And the model representation G and the score functions that we use, right, will sort of align and decide how the blender does, where the data in some sense is the input to that. Although I'll unpack a little bit like what we're computing in a little while. But what's important to me is that these two things go together, that conceptually we can separate them, but really when we're talking about like the process of the information, right, there is a go-between, right, that the data that is collected and judged to be worthy of storing is related to what can possibly be processed. Literally, the way we design the hardware that will be processing it and the algorithms that will be used in the computer code that will be processing it, right, take into account the type of data that we have. That we can't say one is fixed, right, versus the other, that they're both co-evolving together in social systems, for some purposes. So instead of ML, if I was going to give a much longer definition, it would be social human data processed by flexible algorithms to create computed models that inform decisions. But I'll just say ML. And again, like there are many very, very important uses of machine learning, like as I've defined it, that we should be excited about. So machine learning, as I've described it on digital trace data, it's not going away. But just as the interaction between the digital and computing pieces are co-evolving, I think we need to be intentional about the future of each different piece. And quite frankly, I think computational social science has a responsibility to contribute to what the tasks should be, what type of relevant experiences are there, what the model representations should be, and the score functions. And they shouldn't simply be in the aggregation domain that I've talked about. So, again, I got involved in this. So my journey was like, cool, right? I'm super interested in, human rights. There's all of this deep contextual data in text. That's available. So we started the Pulsar project, the parsing unstructured language into sentiment aspect representations. I named it, but can't say it, I guess. And really this brought together the collection of textual data, machine learning models that were going to process that, and supervised learning tasks where we use human annotations on these documents that have been done for 15 years prior or more, where humans had read these and assigned a score. We've also used machine learning in the part of the violence early warning system project with the University of Uppsala to inform peacekeeping and inform knowledge about where violence is going to happen, both at sort of the country level, where should we pay attention, but also at the finer granularity of subnational regions, what we call like grid cells. And so let me walk through like our steps of like interesting machine learning can do interesting things to us as we build and compute models, but then also sort of focus on the discrepancies and model criticism piece that led us to think that today's tools are not sufficient to what we need and sort of not up to the challenge of what we want to be accomplishing. And that might have some very important systematic and systemic components. So human rights organizations, they encode their observations in text, these reports. For years, social scientists have read these texts and given them a score, right? So you read it and you say, oh, like, a 3. So this is like a coding process. And the one popular scale is the political terror scale, PTS, where 1 is, good, you're Norway or Sweden, and 5 is a very bad score from the sense of human rights, where there are routine and extensive human rights violations that are occurring widespread around the country. And so we built models, basically, taught machines, both ensembles and individual learning representations, right, to read these human rights reports and be able to predict the scores. We did it in a nuanced way because we kind of knew where we were going, in the sense that we knew there might be changes underneath the hood. Although when we started, we were less clear about where those changes and inconsistencies were. And so I'll get to that. But we could measure how well our model did over time. If you just stopped with the performance metrics like precision, recall, and F1, like by standards of what we were doing, like it was sort of best in class at the time. And so thematically, like what we were doing and what I want to focus on is we were at sort of screen 1 of what I think is actually a 3-screen process that we need to pay attention to in a sort of like fractal way, right? So screen 1 is the idea that like, wow, as a computational social scientist, I have access to the computational and digital revolution. There's people coding data and other things. I can sort of, blend on that data, right? And get interesting signals. And that's what our sort of first go around was. And, lots of people's, especially from social science, first entrepot into machine learning, right? You see people like the golden age of social science. This is amazing. The compute, the digital trace data. Wow. But I want us to also focus like the wow is actually about the control we have over the process, right? So we're part of this screen, right? We decide the tasks, the experiences, and what's going on. There's a lot of control that a computational social scientist has about, what's going on under the hood and what happens. And that element of control, I'm going to come back to a couple times. Now, I deeply like this idea of the iterative process of research. I've always been interested in information systems and how democracies process information. And so with these machine learning results, we didn't stop, right? Instead, what we did, we started looking at, well, what were some changes over time? What do we see that seems inconsistent? And in fact, there was a fight about sort of whether coders were inconsistent, whether human rights was getting better or worse. And we were trying to sort of wade into this debate of measurement, where our measurement models, sort of Bayesian measurement models biased, were the humans biased, like what's going on here? And we sort of entered this with a machine learning look at it. But in doing that, we had to look at the discrepancies and build our domain knowledge in some sense of like the distributions of scores and estimates, and then go back to the texts and, what were we doing well? What weren't we doing well? And what you can see is that over time, different features, and here, like we used a very simple representation of text with some domain-centered multi-word expressions and other things, but there were some big changes in what was being tracked in the text over time and their importance in the model, right, as we sort of predicted at different points in time, so sliding windows. I'm happy to answer questions about the techniques of this. But one of the things was the model, like if you fit a model, right, there was actually many different things going on, okay? And for us, this actually fit into like what we had been reading and thinking about in the larger literature about what we can think about as the abuses of machine learning. That machine learning doesn't do necessarily what you think it does or interpret it to do, right? It does literally like what it was programmed to do, based on the experiences. And so anyone that's programmed or done the little coding exercise of trying to direct someone to make a peanut butter and jelly sandwich, I think knows all these things. And so thinking about what wasn't in the model and what was missing, from the inferences, And, our system, when we first built it, the machine learning model, right, thought that child labor, for example, like was a human rights protection, because like, shouldn't kids, like labor is good in the workers' rights category. And there were many other examples like this that without sort of careful reflection on the mistakes that the machine learning model was making, human rights is a very, I think, high stakes domain for thinking about this with both allegations and also like, where do you feel comfortable and not devote your resources to? That those details and mistakes were important. So there's a group of, there's a literature talking about the sort of mistakes that machine learning, and these are all like great books that have informed my, thought process, on this. And so like you might think, well, okay, the model seems like sick, right? In sense, like the model seems sick if it's, saying child labor, for example, is a good thing instead of a bad thing. So maybe not so much, I don't know, the golden age of social science that we're doing. So we look then like what could be, sorry, I just like fireworks. What could be wrong? And we're not going to join the chorus of people. And there's this debate online, and it's bled over into academic research. And you'll see this at talk, where there's a lot of discussion that models can't be biased, that you blame the people, you blame the data, it's garbage in, garbage out. And the sort of the thin wedge of my argument is that that's not right. And that actually misses, I think, what's going to be the systematic effect and the systemic effect of current machine learning technology on democracies and autocracies. That we shouldn't blame the people. So in my schematic, right, generally, oh, the model can't be wrong. You just fed it the wrong data, and you might have, right? Or that's the researcher's fault for designing the research and interpreting things the way they did. These are, I'm not saying these things are not problematic. I'm saying they're not the only problems, that can happen. In fact, our first instinct was to blame the human coders who assigned a score, thinking that, well, they were maybe inconsistent in how they read these reports across, right, different timeframes. But we experimented, we designed a research design in which to test that out. And an alternative theory was actually our second screen in going sort of in 3 screens deep. That like we have a screen and we have access to the digital and computing technology, but people's information, the composers of the original text, people that are reporting on human rights abuses, for example, they also have artifacts from the computing and digital revolutions that are not in the model, right? They're not assumed to be there. They're missed, right, in this process. And then there are levers of control for that information, for the machine learning, even as a service or bespoke machine learning modeling that's going on intentionally. That, I'll just black box for a second. That's coming from somewhere, but it ain't coming from the researcher. And let's put that then in the human rights example. So we had these texts, but the text came from somewhere. For example, the State Department or other human rights organizations, right? They're writing about events and actions, right? So there's things that are happening on the ground, and there's examples of that. Maybe in a data generative process, what we'd love to have is sort of all of the pictures of like everything that's possibly going on in the world, right? We don't have that, but some versions of that are encoded right into the text, and then we're scored. So we have a sort of larger, more elongated, in some sense, a fuller representation of the data generation process that we have. But the data generation process is actually like the modeling process. Like, what do we assume is there in our model? What type of experiences are input to our G of representation? So there's a composition process, right? And there's a coding process that goes into the system of understanding human rights. Our model, the model we had built, not considering composition, was partially blind. And the interpretation then was also, blind to the changes. And what turned out to be like, where do those changes come from? Our work has focused on information communication technologies of, what's available for phones and from satellite photos, NGOs that are communicating and their network and been empowered by the internet. That all of those things, have led to more information and changed the information environment about what's going on in ways that complicate measurement. And if that complication of measurement that is germane is not in your model representation or learnable, from your model representation, problems of inference can and absolutely do occur. This is not unique to human rights at all. The fact that the underlying technology of the day incentivizes some research designs, for example, over others, that it matches maybe when you can ignore measurement, versus not ignoring it. And this will come up when I talk about sort of in different disinformation research, political forecasting, that machine learning is actually part, right, of a system of decision making. So this example really sort of hit home for me of the miscalibrated oxygen meters that were basically calibrated from certain types of skin. And so different skin tones, led to very, different diagnoses, particularly for minorities that, had huge downstream effects. And, we can blame the data, but there's a way of processing the information. The assumptions are part of the model. And so assuming away differences about people, right, the context in which measurements were taken is also part of the model. It's just not part of the data. In fact, the data in some sense is incentivized by the type of modeling technology that we have, right, that can sort of make you famous and publish and other things, there. So I think like there are these micro biases through discrepancy, boxes loop, like we can find individual discrepancies, but we also need to look beyond just the micro biases in specific models. We need to look at these as part of decision-making process where there's systems of information and transmission. So I don't have time to unpack like all of these, but you can imagine in the human rights example, but also in the oxygen meter example, right? There's technical aspects to the sensing of what's going on. There's policy and applications of how people interpret the data, right, as it's presented, like, from models. There's also, political and trust issues, right, about people as information comes out about these systems and their efficacy, right, and not. And I also think there are like existential questions about what we perceive about the world and what we see, in some sense comes from a UI framework of perception, but I think are sort of crucial layers. I don't have time to get sort of into all of them, but I do want to at least temporarily put them at the foreground here. Sorry, can you guys still hear me?
Yes.
Sorry, everything froze. All right. Yeah, so you were supposed to see that. Like that was the information system interacting and filling up. And it was supposed to happen while I was talking, so we didn't have to sit here and waste that. And I'm sorry, that wasn't super worth it. Can I fast forward through it? There we go. So I want to talk about that the problems, or when we think about the biases or the weight that ML can play, that it's not just about the E and the experiences and the data, it's also about the computer code that's available, it's about the tasks we choose, and it's about the scoring functions. So another way to think about this is there's a difference between the model representation, and the computed model that we get, and that when someone sees a micro bias of prediction, like a problematic prediction, we don't necessarily we tend to, the blame game goes right to the data, and then the data is transported through G through F in the forecasting function, right, to the specific forecast, and so we assign blame. But the abstract version of this is the data and the model fit together, they must fit together in a way to actually compute. And so I think of models as sort of like these boxes that have different holes and slits, and the data is the type that can win. And right, we sometimes sometimes we take a box and a set of algorithms, from the shelf, and that's going to incentivize certain data to be input, or not. And I think we kind of take this for granted. I won't dwell on this because I think for this audience, it's pretty simple. The box is kind of the fixed representations, not the computed models yet. The data that we're going to then compute the fitted models on, you can think about as from the external world, like going in. And the idea is that this is technology, and it's not necessarily neutral. In fact, it's probably not neutral, and we should spend some time thinking and pondering. And I think our human rights research is going to give us hints about the systematic bias that's happening, in this. In that, in every place in this model, right, it could be, sort of weighing towards, like, I'll say democracy good, autocracy bad, good outcomes, bad outcomes. But the original sort of 3V's of, big data that are linking together, right? So volume, velocity, variety, right? When those are incentivized by the modeling architecture that's there, right? And those are about certain tasks we can do really well with that type of data and the data that's, available for them. So flat decontextualized data, right, can be great for that. But there might be tasks that are sort of flat decontextualizing that are better for some information systems than for other information systems. ML itself, the model representation, so even before the computed model, the representations themselves incentivize certain types of inputs, right, versus other, just in the cost it would take, to incorporate them. So they influence the distribution of resources, out there, and we should pay attention to those, I think. We know, so there's also there's hints out there. We know that ML, current machine learning technology here, so not so much the research design and flow, but the technology and the sort of stable of algorithms and technology of the day are good for some tasks and not others. So there's, some things we can do fantastic with transformer architecture and some things, we can't. Machine learning for life trajectories didn't work out so well. The authors interpret from a competition, right? Detecting fake tweets, for example, comes with disclaimers, about, lack of out of sample performance, for example. So, simple decontextualized tasks, the yellow sort of T, right? Many independent samples for experience E, right? Performance measures kind of equally weighted bin by bin, also in some sense decontextualized. Right, so digit recognition, even facial recognition, right? Sort of canonical examples where people can work on, and there's a lot. This is not all. The cutting edge is doing sort of much more than this. But in particular, when thinking about sort of the core entrepot of examples and the algorithms that are kind of popular and what they work on, I think these are relatively uncontroversial statements. I would argue we actually need to think about what should current machine learning do. And I'll just talk, I can't say for everything. And part of my point is, that the contextualization of the systems is important. So for human rights research, right, to be empowered and not limited by machine learning, we need to measure systems of information flow and behavior. So we need to be able to go on and offline, for example, and figure out what's happened from, right? We need dependent samples. We know that what's written in a paragraph depends on what happened previously, but also what one human rights group organization might be writing is dependent on another, through linking and sourcing. And it's all of that is dependent also on, for example, where they have locations and people on the ground. Performance measures, right? Cost functions that are informed by policy, right? What's happening on the ground, not simply an abstract metric bin by bin. And, I'll add model representations that we should think about if we're going to incorporate information and multiple screens and generative models. We need to think about bespoke modeling, not necessarily instead of black box modeling, but in addition to, and how we can learn from both approaches, for these sets of problems. So one of the things that we've done is try to build on this. So, Pulsar has evolved to be a graph representation of human rights that includes both human annotation machine and then human checking of what's there, into trying to understand the valence and connections of terms in particular. HRView is a collaboration with fantastic people here at Pitt. That's an NSF project to provide tools so we can look at the data that Pulsar spits out to critique the patterns and learn about the context, right, that's being explicated through the system. And through this modeling, I want to return to democracy. So as we've tried to pay attention to the context and structure, right, we've actually started to try to parse out the reasons behind human rights violations, the tools and technologies of violations and protections, from the check. And this is early work, but what we're seeing is an increase in facial recognition, mass surveillance. sort of, absence of privacy, doxing, being mentioned in human rights reports across, many, many different groups over time. And we can connect them because of our sort of graph structure. We can connect them that they're tools and technologies of violations, right? More than they're just sort of mentions at all, in these systems. We see increases in this sort of, what I'll call ML related tools and technologies of violations in both democracies and autocracies over time, measuring democracy with the VDEM project. But the increase is much greater in autocracies. And strangely, in the paragraphs where we see mentions of violations in democracy, autocracies are named. So there's discussion of what Russia and China is doing in other democracies, right? Hinting at, as people pointed out, there's not really informational sovereignty anymore, within democracies. And I'll get to that in a second about that potential problem. There's no recorded increase in sort of ML powered protections showing up. So those could be there on the ground and they're just not being written about for various reasons, entirely possible, but we're not seeing that right now. So this actually leads to a much deeper question for us, right? About, there's these hints that we're picking up, at least human rights organizations pointing to, ICT in particular, machine learning related and adjacent technologies and systems, right? Sort of, being part of autocratic repression. And if we go back to where I started, right, with democracy and autocracy being flows of information, machine learning for computational social science is a way we control and flow information. And we know that's happening for others too, although we don't control it and increasingly they don't control it either. This sort of system of systems, there's international competition between autocracies and democracies. There's the domestic functioning and social learning that potentially goes on. And the technical systems that we might think about back in the day used to be sort of snow globes of interaction domestically, country to country. At least we thought of like that, like in the United States. Many other countries never thought like that. But right now there's lots of interchange through those technical systems. And so moving over to the right-hand side, this is just a rehash of the slide I started with, that democracy is harmed, right, if it infringes on the ability to learn from shared experimentation. So the lack of control, right, the control that a computational social scientist has is not, right, given like through machine learning to someone who's a user and being used, on their phone, like through Dataveillance and other processes. Right. And autocracies, right, I think it's pretty clear you can think about that even, facial recognition as a service, for example, has some potential benefits, for control or even the perception that it's that it can find people and they can be punished. It can influence behavior and enhance repression. Again, sort of balances. These are hypotheses. This is what we're sort of looking into at different levels now. I think this is one of the great challenges of our time is, can we make social learning and democracies function, like better than it is? And one of the things we decided we needed was sort of more theory of how this worked. So we gave adversarial agents and agent-based modeling sort of different types of services, machine learning adjacent services in the model. So they, for example, can surveil like ad networks, can segment the population in different clusters. We have different networks and different technologies give communication. And if anyone's heard me give this specific talk where we talk about these more, like it is frightening, right? That what you come up with in these models and how difficult it is for a group that lets adversaries, that has technologically accessible adversaries that they can't recognize specifically, that social learning is disrupted. And so we have disruption motivated adversaries that generally do very well if they're trying to break things. Persuasion still is more difficult. I'm happy to talk about that, given that both are definitely important. The outcome of this, the sort of simple takeaway is that, the tools of Dataveillance, both the collection of digital traces, even as a service on people, the experimentation that is allowed for trolls and sort of merchants of anxiety and fear, like, fuels this misinformation and lots of this dysfunction theoretically. And so then the question is like, how can we bring empirics? How do we intervene? How can we help see the system and heal it, in ways, that might be useful? And I think in this case, we need to go another screen deep. We need to realize that there are screens, merchants of anxiety and fear, autocratic governments. So the trolling, there's lots of uses of ICT and machine learning adjacent technologies that are going on that we need to incorporate in our models like I'll say in a system of systems perspective, for lack of a better term for that, to understand, what's going on. And there's some great people at Pitt and CMU doing the absolute best work, on this. The concern is that this is the world we're in or headed to, where people are getting most of their signals, the public in a democracy, digitally, where it's a hall of mirrors and we're not sure what is true or what's not, and adversaries have access. And in particular, right, adversaries can control your perceptions on your screen and what you see, what you learn about the world in the sort of Deweyan and Lippmann sort of way that you don't have necessarily direct experience or even experience with someone who has direct experience. So like what you see, but also, right, these networks and systems don't just feed you things, they collect things on you. And so they also tell adversaries a little bit about who you are and how you can be manipulated. That's sort of the trick of disruption in the models we find, that's out there, that's a really big deal in motivating this, the lack of privacy, for example. Things used to be better. And so I don't have a ton of time to go into this, or really any. But one interesting avenue of this research is the role that sort of analog physical information plays in democracy. And like you think about, like, I used to think that it was the gatekeeper model that kept democracy sane, and at the cost of less information heterogeneity, we got clearer signals from sort of experts where adversarial relations were blocked. That's one of the reasons there was more informational sovereignty. I'm now not sure that that's true. And instead, like, I think analog physical information sort of underneath the hood of our perceptions has played a crucial role in accountability for experts, gatekeepers, and the public in a shared experience that we don't necessarily have anymore. But happy to talk more about that in Q&A. For it. And so this hybrid world we're in, I think where the game's not up necessarily, the physical world is still there, but the physical world, is not accentuated when we think about the power of machine learning and the leverage that we're trying, to accomplish. When we think about, for example, me as a computational social science who's just supposed to compute, but not supposed to go out into the community and think about how that computation is happening. And I think that's problematic. So for disinformation, like, we're trying to change this. The Pitt Disinformation Lab it basically is an attempt to change the tasks, experiences, performance measures, and model representations, that we're deploying towards disinformation. So, we need to measure systems of information flow and behavior on and offline. I think that's one of the most important things. It's not just about detecting, like, a tweet. I think we need to raise the bar and think about these systems of information, both at the democratic and autocratic levels, and how they connect. I've flagged, for that task, right? One of the things is driving out in the community and seeing sort of physical manifestations of, mis and disinformation. So End the Fed from InfoWars is this that I took a picture of a couple weeks ago down in Fayette County. We also sort of the interstices of place and digital. And so local Facebook, place-based Facebook groups that Laura Putnam has really led us on in the Pitt Disinformation Lab. And added to that are not looking at just posts or what APIs give you, but focusing on the social learning and discussion that's happening, right, in these forums, and what people are doing. So not just the posts, but the discussions afterwards. The experiences, expanding that to not just APIs, like sure, Twitter API and CrowdTangle are great, but those are very narrow views that are incentivized by certain specific technologies. But like, photos collected through different ways, map and geo information, focus group feedback, like on how people are using technology and what they care, surveys, right? But also narratives. So understanding the flow of information person to person, where what we're seeing are simply residuals of that communication, right? But it's not necessarily the dis and misinformation itself. That's in the heads and in the belief that's there. But also, so sort of, again, all hands, all information, much more heterogeneous, modeling what's going on. My group has also worked with sort of the problem with scalar performance metrics, where there's sort of one right answer or best answer. And so this is a sort of geographic example over time where we're giving pictorial representations of hits and misses in a model that put them in geographic space to help the learning that goes on. And so volumetric rendering and other engines can be useful for this. And then like adding to our set of tools, bespoke models that are critiquable, again, not instead of black box modeling. So I think definitely like Bayesian modeling, has a role in this where we represent qualitative information, much more easily as priors. We make very specific assumptions that are happening rather than off the shelf. But I think I'm more or less out of time. I'll just say I think where this journey has led me is the need to take advantage of both sides of the computational and digital revolutions. So one side of that is on the elevation here, that there's the digital traces of deep contextual data, but they come from context and place. We have worked a lot over a decade of how we elevate and aggregate those, through technologies. And I would say a lot of current machine learning technologies about that aggregation into inferences where we color countries or signals. And what I also think the role of computational social science needs to be is the immersion of those models and of those inferences back into the context, and tools to do that, visual like HRView, or other 3D rendering and other things, talking to the community. These can be low and high tech. I think is absolutely the future, that it's really not computational social science, it's computational social science in society. And that will help us answer like the future questions, for example, like the bad guys are winning, why, and what can we do about it? I hope and think the Collaboratory can be an incredible vector to bring people together to help solve these problems and change what's going on. Thank you so much for your time.
Thank you so much. That was great. I see people clapping. So I want to invite the audience, if you have questions, you can either raise your virtual hand or type them in the chat, and we'll take some questions. While we're waiting for some of those, let me just start off with a question for Michael. So I'm wondering about the availability of data. To what extent do you feel like you're swimming in data and you have all the data you need, versus like there is some data that would really help what you're doing and you just haven't figured out how to get access to it?
It's 95%. How do I get access to the stuff I need? And it's 5% like this is easy. I have it. That's not how I felt at the beginning of my journey from social scientist to computational social scientist. It's kind of like the idea that because you have more, right? Like, oh, wow, it's more than I had, right? So it's amazing. And so we focus on the relative difference. But once you start thinking about the amount of information that's in these systems relative to the amount of information that Avaya has access to and how relevant that is and the way we set our tasks, like, I don't think we'll ever have enough access to it, which is why like the theoretical modeling that takes into account what we don't see, the creative interchange of like, how can we see bits and pieces, right, of what we normally wouldn't see, right, but now we can see it. I think those are absolutely crucial. Does that answer your question?
Yeah, it does. And so let me just dig a bit more. So in data that you don't have, is it data that exists, but gatekeepers have it and you can't get access, or is it data that nobody's really compiled in one place?
Yeah, so I think it's a mix of both. In the benign case, so I was doing a project on extraordinary renditions, for example, and tracking extraordinary rendition flights to black sites around the world. There's actually quite a bit of data because it's really hard to hide civilian planes because it's such a regulated industry. It's not impossible, but we had data on the planes. And so I worked for a couple years actually on a model that talked about where the CIA wouldn't fly in order to understand sort of systems of national security accountability. And as I went through that process, I realized that my inferences were wrong, because the information we got on the flights, even though like it's a highly regulated industry, right, the actual information, right, came from like legislative oversight, press, right, and individuals, but that cascade was dependent. And so if you just sort of threw those in as features, like, in this country, do they have strong legislative oversight versus press freedoms? You found like legislative oversight was super important feature, right, for predicting where the CIA was scared. But if you went back and collected the data that was available in the reports, like how do we know what we know? And then what was the original source of the information? The press was absolutely crucial, right? The legislatures couldn't have done their job without the press. That information was available. I just didn't think to look for it originally, right? Because I wasn't deep enough into the process and measurement, even though I pay a lot of attention to measurement, I think, right? Like I didn't go that sort of another screen deeper, right? Like where the people that got the reports, where did they get their information from? When we want to study, for example, next door, which we think is a very important like network and representation of mis and disinformation, data is simply not available if you're going to follow, terms and services. There are absolutely gatekeeping for hugely important things. You and I have talked about, for example, like deleted posts, that are absolutely critical to figuring out, was this an example of social learning and someone deleted their post, right, because they found they were wrong and they were embarrassed, right? Or was it like they did their job, right? They sort of destroyed the conversation and then they're exiting, right? So they can enter another conversation without having to be held accountable for having had the opposite opinion somewhere else. So it's absolutely both.
Thank you. Looks like Michael Yoder has a question. Michael, do you want to turn on your mic and ask that question?
Sure, yeah. It's part just a clarification, I guess, on what you mean by sort of that analog or physical information. Because I'm thinking you kind of posited that as more of an influence in the past. And so maybe you could say more about that, because I'm just thinking about, for example, the availability of public images on what Russia is doing in Ukraine as kind of actually a counter to misinformation. So I don't know if you could just say a little bit more about that.
Yeah, no, I think that's great. So I don't want to suggest that we don't have physical reality anymore, but I do want to problematize like the role that plays, right? That common experience, that socially processed information, like what it plays on our ability to have public consent, right, and a will, like in democracy, because I think it's been taken for granted, in some way. And this is complicated. So I don't mean that we have firsthand experience in Ukraine, right, about what's going on. Like it's like Lippmann was right. Like we are all farmers, right, that basically can't see outside of our backyards, like through like direct observation. So there are networks of trust, right, that sort of extend outward. I do think there is a probabilistic interpretation, right, based on evidence, right, as transferred, from physical reality. So I think it's definitely helped Ukraine. It's absolutely helped in human rights, the documenting of human rights violations, for example, right, that we can actually see, for example, with satellite photos, what has happened, cell phone camera photos, right? Again, like there's a little machine learning in there. Those aren't actually the representations, right? That they're digitally processed images to a large extent, like that we're actually seeing, but they can be incredibly helpful for documenting what goes on, right? So that's great. One problem is, right, where do we see it and where don't we? And so there's lots of really interesting sort of Twitter discussion, for example, among international relations scholars about like, are we really getting the balance of casualties, right? When most of our information is being fed through networks that are sort of more pro-Ukraine, right, than Russian, and they don't show their casualties, right? And I kind of want to point out, right, that, because of the digital, like what Laura Putnam calls, and you should have her give a talk because she's amazing and she'll do better than me, right? But the sort of the digital re-intermediation of what's happening, right? That it puts its weight on its scale in a specific way, and images and artifacts, right, that used to be like transmitted through like photons, right, like those are there, right, and they're part of the system, but it ain't just the truth, right, like sort of unallied, uninterpretable. We need to make inference on it. And so, like again, like you're hearing me. I don't have, right, like a great example of it, but like I think it becomes clearer when we think about, well, let's dial back reality. Right? Like, I think that like thought experiment helps us. Let's enter the metaverse. Let's say everyone we care about and all the social value we have, right, is in, right, like some metaverse, right? What's true and what's not? What's control and surveillance? Is there a shared experience, and how would we ever know? I think we deeply lose something, right? I think you can do that if you don't go to that extreme, just increase, like, for example, the use of deepfakes, that look like reality, right? In some sense, it's hedging on our trust of physical signals that used to be so costly to transmit that they then shifted, right, our beliefs and probabilities about the world because they were quote unquote credible signals. That in some ways, the physics of reality screened for untruth in ways that were incredibly valuable for social learning. Are we going, I would suggest that some of that is going away, that as we lower the barriers for the creation of signals, and that is worrisome for social learning. Does that answer your question a little bit?
Yeah, I think it does. Kind of that, looking at that intermediary, like what we're doing with that physical information and how that's circulating in networks of trust. So yeah, thank you.
Yeah, it's a great question. Thanks for.
All right, thanks. I think we are about out of time. So thank you very much. This was an excellent talk. Please join us again for our next seminar, which will be on April 12th at 2 p.m. and will feature Kathleen Carley, who is Director of the Ideas Center at Carnegie Mellon. So thank you, everyone, and see you next time.
Thank you so much.